versus impersonal secrets.
And we're live. Welcome back to another Corona Geek. Here we talk all about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and today we've got a handsome panel. Joining us is Dr. Brian Burton down in Napoli. Also joining us is Ed Marina from RoamingGamer.com.
I know you're referring to Stitch as the handsome one here, though.
Yeah, well, absolutely. You know it. You nailed it. Also joining us is Mike Hinckley from CraveCreative.com, and we've also have Stephen Johnson from ZevolvoStudios.com. And of course, I didn't mention, but if you are in the market for a book on how to program using Corona SDK, then you need to go over to BurtonsMediaGroup.com, which is Dr. Burton's website. And Brian, you put something online, was it over the weekend that said free updates. Tell us about that.
Yes. If you purchase a copy of the book through my website, you can get updates for free for as long as we do this. And we're going on 5 years now, so still going strong. Of course, you can also get updates through Amazon and through Apple, but I have no control over how quickly they push those updates out. So if you want updates quickly for all the changes that happen to Corona, improvements that are made to the language, right now I'm updating Chapter 4 of the textbook, where we talk about using text fields and text boxes. Of course, before we couldn't do that with Windows. Now we can do that with Windows in the simulator. So I'm updating information on that chapter about things like that.
Okay, excellent. Yeah, and so just for anybody who hasn't watched the show, and we've said this a number of times, but I think it's always interesting that when people finally clue into something or it finally comes on their radar. Dr. Burton has published a textbook that is used by colleges, universities, high schools. And as part of that, when you buy the book, you get updates to the book. And so unlike a physical book that you buy and is printed and is out of date pretty much the moment that it goes to print, his book gets updated on a regular basis. So if there are new things like, say, Apple TV or, like the text boxes and things like that he was talking about, then those things find their way into the update. And I think that benefits the purchaser, the reader, highly, and I can't recommend it enough. So if you guys haven't already, go to BurtonsMediaGroup.com and check out his books on Corona SDK.
Thanks.
Yeah. All right. I've got a couple of announcements before we open it up to the panel for announcements. One is that the commercial break plugin is now available for Corona. So if you guys haven't seen that, go over to the blog, coronalabs.com/blog. There's a blog post there. We'll link to it in the show notes. But commercial break is essentially the opportunity for a viewer to watch a series of video ads and then get rewarded in your app in some form. So instead of calling it ads, here, watch an ad, you're watching commercials. It's just like television. You've got 3 commercials in between some activity, and that's a form factor that most consumers are used to, and you can reward them based on their participation. So I think this is a great new way to monetize with Corona apps. So if you haven't noticed the trend that's going on here, lots of monetization plugins coming out, lots of opportunities to make money using Corona, and just keep on rolling with it. So go check that out. There's a video there on the blog post that tells you all about how the program works, and there are also there's code there and links to documentation and everything else that you need to implement it into your app. Also, there is a new Corona Canon sample app. This is a rework of the old Ghosts vs. Monsters, if you guys remember that from back in the day. Sergey Lerg, who is now working at Corona, took that demo, that sample code, and reworked it into what we're calling Corona Canon. And essentially, it is the same sort of Angry Birds kind of form factor, and mechanics and things like that. But he's updated the graphics. He's updated it for Graphics 2.0, updated it to all the modern best practices for Corona, and it also works on Apple TV. So if you are into doing something like that. It also has iCloud support in it. So go grab that sample. We'll link to it in the show notes. Go grab that sample and check it out. It's a good example of how a project should be structured, how to get things working with Apple TV, how to work with iCloud, how to do certain mechanics like being able to apply force to a particular action when you're aiming the cannon and then pulling back and trying to get the force at which the cannon ball should be launched. All that stuff is in the sample, so go check that out. Also, this Wednesday, we're going to have Corona Geek After Dark Hangout. We normally have those on Tuesday nights, but what we decided to do is we're going to try to put those out on a regular basis. Not by regular, I mean we're going to do those once a month, and we'll try to do them all at the same time. So we were originally going to do that tomorrow, Tuesday night, which would have been the first Tuesday of the month. So we're going to try to do them the first Tuesday of the month on a regular basis. But then in this particular instance, another event coincided with it, conflicted with it, so we decided we'd just move it to Wednesday. So hopefully you guys can join us. We'll be online at 6 p.m. Pacific time, and we'll talk about monetization. Also coming down the line is a new website. The Corona Labs website is being revamped in look and feel and also in structure. We're going to move some things around, make some things easier to find, and that's coming soon. And on top of that, we are working on Coronacron. We are planning the pieces and parts of Coronacron, so look for a form coming soon where you can register either to be a speaker or to express your interest as an attendee. And also just to be able to give suggestions about topics that you would like to see at Coronacron. So that's more details on that are coming soon, but we will publish the initial sign-up forms shortly. That email has already gone out to all the ambassadors, so we are getting feedback from them as well, and giving them an opportunity to raise their hand as speakers as well. So it's going to be a good show. Speaking of shows and showcases, we are going to also be pushing to feature more apps. So one of the things that we want to do is showcase apps that are out there that have been published in Corona. And we also want to do case studies. So we have a form coming for that, for case studies and showcase, where you can basically submit your app for possible inclusion in one of those as well. So look for that all coming soon. And we'll have links to everything in the show notes that I mentioned. Now, that's enough for me. Anybody on the panel have anything that they want to share or announce or whatnot?
The only thing that I was going to make a shout out about was obviously Parse made their big announcement the previous week. And I just got an email from Pushbots today, which I tweeted out, but they have they've kind of come forward and created apparently a really easy way to migrate your Parse to Pushbots. So I'll post that in the notes there so you can put it on the thing, but there'd be so maybe people will be interested in, whoever's using Parse.
Yeah, it's interesting. Chris Byerly, of course, he's a developer of Coronium and our de facto cloud guy. He immediately saw that, and when the open source project kind of dropped for the backend Parse server, piece, he went out and put a container on it and started his own sort of work on making it something that would be available. And so what we're trying to do right now is we're trying to figure out what the best approach would be for the community. How do we give them an option that they can use to be able to continue their Parse implementation? How would that fit in with our plans for Coronium and things like that? So he's working on something like that. We hope to have something out soon, either as an official Corona Labs thing, or just maybe just Chris pushes something out that he's been working on for the community as a whole. He's very community minded like that, and saw that there's definitely going to be a gap with Parse basically shutting down their service. It's crazy.
And let me talk about that for just a moment. In Coronachronium IO, which is what Chris has been building and working on for some time, there's already support for Pushbots. So you can use that without any problem. If you want to just do a hardcore shift over to that can be done. And then, of course, you can use the Pushbots tool for migrating your applications over to their service. I've been using pushbots for some time with Chromium IO, and so it's fairly simple to use. Chris keeps making this better and better. If you're going to stay with Parse and use the server tools that they're providing to everybody, which is fantastic. You know, you can set up your own Amazon or Google server or DigitalOcean or whomever you happen to choose to use, and set up your own Parse server and continue using it. You're just simply going to redirect to your materials instead of to the Parse server. So both are going to be an option. Chromium IO is a solution for both directions that you would want to go with that.
Yeah. Yeah, it was quite a surprise, I think, for all of us. We were just kind of like, there was no real lead up to it. It was just sort of
just suddenly gone.
Yeah, just a Dear John letter in all of our email boxes. Okay, excellent. Anything else? Anybody else? No? Okay. All right. Let's go on and get into what we had for today's topic. I think when last we left, we were going to talk about object caching, and it seems to me that the questions were something along the lines of what is object caching, what is it good for, and how often should you use it? Is that a fair assessment?
I'd say that's a fair assessment.
Okay.
Yeah. So to go on the Wayback Machine, or to jump on the Wayback Machine, or however you want to put it, I'd heard many times from people in the forums, oh yeah, I use object caching. Use object caching. You know, people would give advice. I'm like, object caching? Well, that seems like a lot of extra work to get just a little bit of benefit. But then the issue is that I never really investigated it. So starting last week, we got serious about this. Actually, when we did this game, I got serious about it. But last week, I put together a small app, which we're looking at here, for people to run and give me some feedback on. Now, I ran it on a couple of my devices, and I had some other people run it on their devices and post their results in the forums. And before I show you the graph, what I thought I would do is just show you this app. Basically, it's very simple. Now, I should point out that it's pretty much useless to run on your desktop because you're going to get weird results for the frame counters for whatever reason. I don't know if it's something that's just about my desktop or if this is common for discrete video cards. But whatever the case is, you need to run this on a mobile device, and we'll give the link again at the end of the show for people who are interested in running this. But basically, you go in here and you run it, and you're going to be presented with three options: some red numbers, some green numbers, and then the option to use caching or not use caching. Now, the idea here is that you want to run one of the four tests. So the first one is circles, the second one is rectangles, the third one is images, and the fourth one is a sprite test. And then you want to select a number of objects to create, and the way this works is every other frame it creates this many objects. So if we selected 1,000 and we selected option 1, it would, in one frame, it would create 1,000 circles. In the next frame, it would remove those circles, and then in the frame after that, it would create another 1,000 circles, and so on and so forth. And what we're trying to do here is we're trying to punish the device to the degree that the frame rate dips. So what you need to do is kind of run this once, quit the application, run it again, and find a suitable number for, just start with circles and use caching and not caching. And my suggestion is that you first select test 1, some value, say 1,000, and then use caching. And what you're looking for is a frame rate that dips below and stays below 60 frames per second, because this is going to be your reference setting. So once you've got a reference setting, then you can run through the other tests, so 2 and 1,000. And I wasn't very clear about this in the forums, but for people watching this who want to run it again later, just stay with the same numbers and then flip back and forth between caching, no caching, and then run each of the 4 tests. So for example, if we did the sprites test, 1,000, and caching, this is kind of what it would look like. Of course, as I said, the frame counter gets all goofed up on the desktop. But enough about settings on the desktop. Let's just get to the results. So far, I have to say that I was highly surprised by these results. And in fact, I have to reverse my position on caching. It might be worth doing it almost all the time. In the case that you are producing many objects in a small period of time, and those objects all use the same builder. So a situation where that would make sense is if you're producing lots and lots of your own homemade particles like we do in our game. We're making a bunch of lines or circles, depending on what option we've selected. And if you produce many of these, it might be worthwhile to cache those and then reuse them on the next time around when you need another particle element. So let's look at the results for Apple. So for mine, another thing I forgot to ask people to do was tell me what operating system version they were using and what build they ran with. So I'll amend the forum post a little later today, so if people put more results in, if you're listening now or if you read the forum post, try to give me both your iOS version and the build version of Corona that you used, because I'll find it, I think, if we get more and more numbers, it might be interesting to see that we'll have slight performance differences across different devices, different operating system versions, and then different versions of Corona. In fact, we did see this a little bit, and I've got Mike. Mike gave me some data here, and his data is slightly different. So I'm going to ask him when we get to that point if he remembers what iOS version he was using. But iPad Air Generation 1, that's mine. The first chart we see here, it might be a little bit hard to see. Can you guys see that okay?
It's a little small, but I think it's readable.
Let's see if I can zoom in. Let's make this full screen.
That's much better.
There we go. So the way this is organized is, unfortunately, it didn't respect my ordering. So here's my chart of numbers, and here's the chart of the actual bars, and it didn't respect it. So new circles on the bottom. Anyways, new circle, uncached versus cached. Basically what you can see here is the second bar, every other second bar, or every other bar is the cached version versus the uncached. So uncached, cached, uncached, cached. And this might be a little bit hard to read. I've got another chart below, but as you can see, every time the cached severely outperforms, the frame rate is much higher for the cached versions.
So the bottom scale there is frame rate. So the longer the bar, the better.
Yes, larger is greater. I tried to put together a better presentation, but I couldn't get the Open Office to I'd copy these things into another app, and then I'd lose some of the data. So I said, you know what, this isn't worth it.
It's okay. I think as long as people understand it's 60. Our benchmark is 60 frames a second, which you have there, 60. And so,
right. So 60 is my basis, yeah. And basically a longer bar is better.
Yeah.
And then if that's not clear, another way to look at this is basically a percentage of improvement. And this is caching versus non-caching. And so for new circles, on the iPad Air Gen 1, iOS 9.2, version 2809 of Corona, so fairly recent, circles get a small improvement. This is no surprise because the circle is a very simple object to create and to render. Similarly, rectangles, I did not expect those to be a significant improvement, and they weren't. They were only about 18% improvement. But the big improvement and the big surprise, really, it shouldn't have been a surprise, but it was still, is new image rect was a huge improvement. It was 140%, almost 140% improvement over the base frame rate. So more than twice as fast to cache images and restore them. And I guess it just shouldn't be a surprise because the amount of data that you're moving when you create a new image is significant, and you're involving a lot of different pieces of hardware. So parts of the OpenGL pipeline. I mean, there's a lot going on there.
So are you saying, just for reference or comparison's sake, we're not saying that new image rect is faster than new circle. We were just saying that the benefits show up greater in new image rect than they do in new circle. Is that what we're saying?
Right. These are not comparisons of like saying that new image rect takes longer than new circle or is like twice as long or anything. These are only relative to each other themselves. So for circles, for a call to new circle, what I'm saying is that cached is about 42% faster than creating a brand new circle every time. So reusing circles versus creating brand new circles. Creating new rectangles every time versus reusing rectangles is, well, I'm sorry, I said that backwards. Reusing rectangles versus creating new rectangles is a little bit faster, but the biggest improvement we see is when you create a new image rect. If you cache them, it's significantly faster than creating brand new ones every time. And strangely, when I saw that, then I expected the new sprites operation to be also at the same level, somewhere around thereabouts. But for whatever reason, actually, I've got a clue on this one. The reason we don't see a significant improvement in new sprites is because sprites are in fact caching. What happens is you create the first sprite and it caches the image data in video memory, and so you get the benefit of that cached image on subsequent creations. Whereas here, we're getting hit every time because it can't optimally cache the image that it's pulling to create the new image with. So that's, as a side note, is a worthy mention to say that sprites already have a built-in optimization value. So let's just look at some other numbers, and then we can take a look at the code. So I don't remember who it was right now, but somebody else sent in details on the iPad 2, Generation 2, and similar looking chart. So that's the iPad 2. This is I mean, it's almost exactly the same.
You would hope you get those similar results. I mean, the hardware might be a little different, but overall, you would hope that you'd get.
Well, that's the thing I was gonna. I'm glad you said that. That's a perfect segue into the next chart. So the next chart is Mike's chart, and this is from Mike's data. And this I was very surprised at. Now, one thing I do know is Mike did something a little different, in that he chose different values for each of the types that he was creating. So he was creating 1,000 circles, but 700 rectangles and 300 image rects. So these are not apples to apples graphs. Now, again, we're not comparing these to each other, but they don't have the same basis. So that's a different kind of thing. So they don't have the same basis for the generation of the data values for each. But regardless, I still expected fairly consistent values. So this tells me
I'm a little lost there. So what was the difference? What's the primary difference?
Okay, let me back up. So whereas for every one of mine, I created 1,000 circles, 1,000 rectangles,
Yes.
1,000. I took a factor out of this. So they're all consistent in the sense that they all create the same number of objects.
Okay.
So these are, in a sense, apples to apples on the basis of the test.
Right.
We're not comparing circles to rectangles, but we know I don't know how to say it other than that. I mean, each of these is relative to themselves, but they are also relative to each other in the sense that we create 1,000 circles, we created 1,000 rectangles, so they're very consistent across the board test.
Okay.
So we're exercising this in the same way.
Ed, if I could interject on what I did, which I didn't
Sure.
do exactly the way you did it. I actually only provided new circle. I didn't go through each one of the different things.
Oh, did
But
I read the data wrong?
Yeah, so I think mine's all based on circles, and it is
Oh,
just
well, that
based
would
on
make sense then.
different amounts that's being used.
Okay. Okay. So everybody who's looking at this chart right now, I'll correct it before I commit it. But each of these should read new circle, and each of these is with different numbers of circles. So 200 new circles versus 300 versus 700 versus 1,000. Oh, that makes this chart make more sense.
Yeah.
Yeah, because all those, they're different numbers, but they're different numbers across the
Because what I
same
couldn't figure
type.
out was why on the iPad 3, which is a new hardware, piece of new hardware, why would the image rect be so out of sorts with the rest of the data I was seeing? Okay, that makes a lot more sense. And this is a valuable test because it tells us that for different quantities, we get different benefits. So let's
Right.
see.
And that's actually the reason I did it is when I looked across the different ones, it was similar. Just as you saw that you got better for the new image rect and stuff like that, I saw that they all seemed to be better in a certain way. So then I wanted to see how well it performed at different levels and at what, where it dropped off. Was there a point where it dropped off more dramatically or leveled out?
Okay, so here I've changed the chart just for our discussion. From left to right, this is 1,000 new circles, 700 new circles, 300. So it looks like our peak improvement is somewhere between 1,000 and 700. It's like at 1,000, the improvement starts to fall off, but somewhere in here is a sweet spot for where we get the most improvement for circles. So yeah, this is an interesting.
So that would be interesting then, Ed, for you to go. I mean, yeah, put you to work
Go
here.
back and generate some more data.
Well, for each type, because he's done it for circles, and then you could do that for rectangles and whatnot, and just to see.
Yeah, I don't want to give Mike more work or even suggest it, honestly, but I do want to suggest that people who are listening, they go do this. Run this test. It's very easy to run. Yes, granted, on smaller screens, it might be a little bit hard to click on the numbers, but this is a very easy test to run, and the code, as you'll see in a moment, is fairly straightforward, and I want to talk a little bit more to that, but the point here is that you can tweak this code in this example to decide early on if it's worthwhile for you to do, because everybody will have a different scenario when they're deciding whether or not to do this. Let me just pause right there and not say anything more because I want to talk to that when we're looking at the code.
Well, and Ed, I mean, to me, what you touched on there is that there's a peak, there's a diminishing returns, right? At some point, yes, you get optimizations, but it would be good to have that chart and be able to see that, that my peak optimization is at 700, objects, and then based on what you're trying to do in your app, you would know kind of what to expect. I mean, just
what I should do? I should just totally go the next step and automate this test, because I could simply automate this test to pass through all of the different examples and simply collect the data for uncached first and then cached second. And then, yeah, I'll do that. So people can run this test and it'll just dump out the results for the whole series. So, yeah, that'd be easier. It'll dump to the console. So oh, no, it won't. We'll figure something out. But, yeah, because you're absolutely right. You need to look at both types and quantities. Yeah, you're not going to get the perfect answer based on just spot checks.
Yeah.
Because depending on how many objects you're creating, different factors will start to dominate the performance, like memory bandwidth or memory consumption, video memory, video hardware. Another one we haven't considered here is the size of the images you're creating. So maybe for really large images, we get even better benefits, or worse, or it's moot. Depends. So those are all things that you can examine with this code. And what I can do is I can make a small tweak to this to make it easier for people to just plug in content and run the whole series and see what they get.
As you're saying that, this almost sounds like a tool.
Yeah, I'm almost thinking maybe I should just leave it as it is and make a little tiny tool for people.
Because when you're creating your images, you want to get the best image quality, but you also want to get the lowest image size, file size, and so how do you know what that is, right? You can kind of guesstimate and say, well, it looks pretty good like that. But that's that's a big size, file size, and maybe I can compress it or tweak it and still preserve the image quality, right? So you kind of like play around with numbers until you're happy. But what if you could run it through a tool and then it would give you like this image will optimize at this size, right?
Yeah, like 256 is good, but 340 pixels wide, not so good.
Yeah, because it'd be great if they could like take the image and like give you versions, right? You could look at it and say, oh, maybe I don't know, maybe some of there's tools out there that already do that, but.
All right, so let me just finish off the data here and then go into the code because I'm going to run over on this topic and I don't want to do that. So that was iOS or Apple. So what about Android? We didn't have as much Android information. We have Samsung Galaxy Tab 4. I don't know why I said iOS 9. That's wrong. Sorry. I think this is running. What's the latest? Not Google M, but Lollipop. I don't know what version of Lollipop it was running, but it was running Lollipop. And 2016-2809, same build of Corona. And again, same basic results. New Circle is actually a little bit better. New Rect, pretty much, these two flipped. I think New Rect previously was better. Let's take a look there. No? 40%? 10%? Okay, yeah, so that's fine. 10%, 20%. So we didn't get as much of an improvement for circles. And again, we got a major improvement for New Image Rect, but not anywhere near as high an improvement or as great an improvement as we did with the Apple devices, which were well over 100%. And here, we were at a mere 72% or so improvement. And then new sprites were also lacking a little bit. They were also, it was an improvement, but not as much of an improvement.
I wonder why that is. You think it's back-end system, or you think it's hardware?
I think it's a question. There's so many factors here that have not been explored. Like I did not explore the question of power of 2 images versus arbitrarily sized images. Now those will get handled differently, and you'll have performance corner cases for those on different kinds of hardware. Size, I didn't explore the sizes. I think the size I used was like 300 by 300 or something. I can't remember the image size right now. Let's take a look here. Where are you? Smiley, tell me how big you are. 128 by 128. So this is a power of 2 texture, very small. So I didn't explore non-power of 2 textures. So maybe there's something about that that's affecting this test. So final data that we have here is for the HTC 600, which the user told me was a small device. I'm not familiar with it, but and the thing that I find most interesting here is that on this device for this test, the new Rect and the new Image Rect were pretty much on par with each other, which was extremely surprising to me. This is telling me that something in that graphics pipeline is dominating the performance over the texturing portion of it. So the texture portion has no base, it's not affecting this at all. Some other detail about the way rectangles are being created is goofing this up.
Interesting.
Yeah, so I'd like to see more data on that too, but unfortunately I don't have the HTC 600, so I got nothing to check it out on. All right, so let's take a look at the code. Since I kept saying, let's look at the code. Let me bring the code up. This code's already been released, and it's in the Hangouts, Corona Geek Hangouts, on my GitHub under Tips and Tricks, Object Caching. And there's not a lot of code that you need to look at. Basically, the only code you need to look at is the top of main Lua, and then the particle manager.lua file. Everything else in here you can just ignore as far as being relevant to this discussion. Let me get my camera up here so I know what's going on. Okay, so top of the file of main Lua, I just I hide the status bar and set the buffering as usual for output. I include just the SSK core stuff, that basically the features I can't live without, I use all the time. I start up the meter, my rudimentary frame counter and memory counter, and then I load the particle manager. That is, I require the library, and I keep a reference to it here. And then the guts of main Lua is in run test, and I have this function called run test that takes a number between 1 and 4, which is the style of test or the style of object it's creating. Circle 1 is a circle, 2 is a rectangle, 3 is a image rect, and 4 is a sprite. Instances is the number of objects to create. It goes with that number that we selected previously. Let me see if I can bring it back up here. So that's the green numbers here. And then true or false to use caching. So this is just one function that does the whole job. And the way it works is once you come in here, we localize the random function so we can get as much performance out of that as possible because we're going to be calling it a lot. I keep track of the objects in a variable. Let's see, I keep track of the current frame. And so as I said previously, the way this works is in the enter frame listener, we see are we on an even frame or an odd frame. On even frames, we create objects. On odd frames, we destroy them. And destroy them is, we'll look at what that means in a minute. So destroy is really calling a method called release, which I've attached to these objects. And that release method will either, in the non-caching case, actually destroy the object, remove it. But in the caching case, it will say, oh, I need to hold on to this. Let's put it in our bucket of unused objects, and we'll get it back later when we need a new object. So but there's not much to this loop here. So in the case of creation, we simply loop for I1 to instances, and then we request an object from the particle manager saying, give me an object of this style, and I am either using caching or not using caching as set in the call to run test. And then just for fun, I do a little bit of work, and that little bit of work is, and this is the part I wanted to point out. This is the piece of code right here. If you're taking this example and you're trying to truly evaluate the value of doing caching versus non-caching, you need to make a decision based on what kind of work you do after you create the object. If you're just creating an image and you're placing it in a location, then simply take out this line here and keep the randomization, because that's a good evaluation. But let's say that you're doing some arbitrary scaling or some other stuff, then you might want to put that code in here. The steps that you would normally do, put that code in here because that's going to affect your results a little bit. It's not just a question of the creation cost, but the steps that it takes to both modify that image, and then in the particle manager, when you recycle the image, you'll have to undo that. And what I mean here is, let's say, for example, you create an image, and you arbitrarily scale it to be twice as wide and 3 times as tall. And then the next image you create is 3 times as wide, 5 times as tall. And you're just doing this continuously based on the needs of your game or your application. Well, before you can reuse that object, you have to undo that scaling. Or you have to find a more efficient way to manipulate this data. But what I'm saying here is the recycling portion of this code needs to sort of like take that object and put it back to its initial state so that when you grab it next time, it's like you created it fresh.
So if I understand correctly, you're saying that if we just slapped an object on the screen in the same place every time and didn't do anything in particular, we would get one set of results. But if we then moved that thing around or rescaled it or did some sort of additional actions, that we would get a completely different result, so we would want to.
You would get different results.
Yeah,
your results would not be accurate as compared to your true usage.
Right.
So this is the part where you need to decide, you need to inject your little bit of code. So this section right here, inject your own modifications.
Would it be fair that to take this piece of code and run a particular series of steps in it, just to kind of stress test, if you will, different pieces of your app? I mean, could you like sort of performance tune that way, or would you?
Yeah, I mean, this would be a good way to grab. You're not going to be able to. Okay, So caching or not caching, regardless. If you're making these changes to the objects, scaling them, coloring them, rotating them, I don't know, applying a transition to them, things like that, all of those things cost. And regardless of whether you cache or don't cache, you're going to be doing that operation. So this is not a tool that will allow you to measure the benefit of modifying that. You're really not going to. I mean, in theory, you could put your code in here, and let's say, for example, you're trying to decide, should I use enter frame to move my object, or should I use transition to move my object? Now, I'm going to tell you to use transition, but you know, far be it for me to tell you what to do. You could put your code in here and run 2 different versions, and you could use this setup to test that. But that's not what this is really designed for. The real answer we're trying to get out of this piece of code, this example, is purely whether or not caching an object is better for your case than not caching it. Now, not caching it is always simpler because of this exactly. Not caching it, you know you get a fresh object every time you create one. It's like if you create a circle and it's got a radius of 10, you know it's going to be white, you know it's going to have a radius of 10, you know the x scale is going to be 1, the y scale is going to be 1, the rotation is going to be 0, you know all these things are set to their default values. But if you're caching and you get an object out of your cache, you don't know what state it's in. You need to reset those values to be appropriate to your usage. So the question is do I reset them when I recycle, or do I reset them just as I pull it out of the cache? Now those are optimization choices you can make, and those are the kinds of things that you need to modify in the code that I'm giving you here when you run this bench, when you run this test bench. Now this is an advanced topic. So I know that this might be a little bit puzzling for some of the listeners, but again, I just want to come back to the premise of this. The premise of this is we're trying to answer the question, based on my usage, is it better to cache or not to cache?
Well, and I think it's, you know, while you're there, I think it's important to point out that nobody's saying that you have to do this in order to have a game that performs well, right? If you are at the point where you are questioning object caching, you probably are in an advanced portion of development, and you will be able to understand and use the concepts that you've mentioned before, right? So if you're just starting out, you're just new, you're like, hey, I want to create an app, like what is all this object caching stuff? Don't worry about it, because you probably don't even need to worry about it at this point. But if you reach a point where you're like, hey, I need to squeeze some more juice out of my device, or a user's device, then you can kind of come back to this and say, okay, object caching, how does it work, and should I use it?
Absolutely, you are absolutely right. The only thing I would add to that is never optimize first. Code well, do a good job of coding, but don't try to optimize your code in advance, because you're just going to hurt yourself. You're going to take longer to write the code, and you may make your code harder to read and harder to remember what you did 2 weeks later. Get your game or your app working, and then find the parts that are slowing you down and fix them.
You heard it here first. Don't hurt yourself.
Don't hurt yourself if you can avoid it. So let's take a look at particle management.
Quick, Ed, if I could interject something,
Sure.
just for the people who maybe don't know this, but you have a great tool already that does a lot of this. It doesn't get to this point where you're just pulling out a specific thing and trying to test it, but your super meter, which people can purchase and utilize in their app, can help them also with some of these kinds of things, right?
Yeah, actually, our RG Supermeter version 2, which is still available, it's a little bit old, but it still functions quite well. It's starting to show its age in terms of like just beauty of the interface. I haven't improved the interface to make it more beautiful, but functionally speaking, it still splits out all these performance metrics, like how much main memory you're using versus how much texture memory, and also it talks about frame rate, and it does a lot more than these basic meters that I'm giving you here. It's much more accurate than the basic meters here.
Right, and the other thing is that it's running in your app, so you're not taking pieces of your app out like you are here, kind of, and testing portions to see how they perform. You're seeing it in the app with your super meter, which is if you want to take it that next step, something like the supermeter may be, logical.
Which I think gives you a much more interactive visual result at the end, right? When you're, I know that when you bring up an app and you bring up the supermeter, and then you look at what's happening on the screen at the time that the meter is either dipping or spiking or whatever, you can kind of get a general feel of, oh, I see what's happening. As soon as this object comes on the screen, the performance dips, right? And you can kind of correlate that one-to-one.
Right. It's absolutely. You can modify it. I don't want to keep upselling. I'm glad you brought it up, but I don't want to spend too much upselling the supermeter. But you can adjust it and tweak that much more than you can these meters, so that it's like sampling at a certain rate, gives you additional feedback. It tells you a lot more than this. So there's a user guide. I say go get it and run it if you've got a question about the performance of your app, and it'll tell you right away if you've got an issue.
Yeah, we'll link to it in the show notes.
All right, roger that. Now, I just want to say thanks again, though, Mike, for bringing that up. I'm so shy. I don't like to upsell.
I know you're so modest about it.
I'm so modest.
You
I don't know if I'm
you
modest.
have to think of these in terms of benefiting the user. You are doing a service for the user, so don't be shy about that.
I just try not to use this as a launching.
Right.
Right.
Yeah.
So, okay, Particle Manager. I'll just give you guys the rundown and tell you what's going on here, and so users can take it apart and do what they want with it. It's a module, and so at the top I say local particle manager. I could have called this public like I often do, but sometimes I call it public. Sometimes I give it a name. This time, giving it a name made sense. Create an empty table, and then before I start adding any functionality, I'm going to localize the display new circle, new rect, new image rect, and new sprite. And this is going to give me a little tiny speed up that's going to be significant in this case, because when I create these, I'm going to be creating a bunch of them. For example, at 1,000, that is creating 30,000 new circles or new rectangles per second. So every other frame, if I'm keeping to 60 frames per second. So 60 frames per second, divide that by 2, 30 times 1,000, 30,000.
It seems like it would also provide a level of consistency, right? For testing purposes, you've already preloaded it all, so you don't have to worry about what kind of performance impact it has each time.
Right. This exactly, because there's work involved in doing the lookup. Mm-hmm. So what I want to do is I want to take that work out of the inner portion of the loop and make my test as consistent as possible so that the results are as meaningful as possible. Now, I can't entirely control that, but in this situation, this system, the results are pretty consistent and are, for the most part, not modified at all by anything else. But I just want to point out, one thing I do suggest people do when they run this is run the test and let the frame counter settle out and then wait a few seconds. Because it's a running average. I think it's averaged over 2 seconds. So once the frame count goes down to a certain value, and then you give it a few seconds, it should stay there, and that's going to be a good estimation of the actual performance. Okay, the only other little bit here at the top that is set up is I created a very basic, you'll have seen this before if you looked at some of my other examples. I create a basic sprite sheet and set up the animation data to create a sprite. And then here on line 28 and 29, I've created 2 tables for the case when I'm caching, and one of them is a table to contain my currently unused objects that I can reuse later in caching. And then if an object is used, I track it in the used particles table. So this is a very rudimentary tracking system, and by all means there are other ways to do this and perhaps more efficient, but what I'm doing here is more conceptual, and so I want it to be straightforward for people. So I have one for objects that I can use in my caching scenario, and then I have a table for those that are currently in use and they're off limits. I can't use them. Okay, so at this point I start to add functionality to the module. I have a function called reset, and this is just a convenience function that lets me go through and remove all of the particles from my particle manager and sort of just like start it over again. So this isn't used in the test, but if you're using this code as a basis for something that you're writing in your own app, you'll want to have a convenience function like this so that when you quit your game or you exit a level, you probably want to recycle all of the particles and get rid of that stuff, depending on your usage again, because you may be doing a much more complicated caching scenario, and it just makes sense to clean things up if you're leaving a level and then coming back to a different level later. I have a function here called getCounts, and this is used within the code, but you can also call it, and it will tell you how many particles are free, how many are used, and then the total number of particles that are in the system in total. The total number of particles, which would be the sum of both free and used particles. And I say particles, I'm sorry, I extracted this code from the game that we're making, so at the time I was doing this, this was all about particles. Really, I could have called this object manager or caching manager, and then I could have called these cached objects and uncached objects, but I think people will get the idea. So if you forget about the word particles and think in terms of just objects, same thing for this purpose. Okay, here's the meat of it. The meat of it is the get method or function. This function is going to create an object of the style that we ask for, and then we're going to be telling it, in this case, are we caching or not caching? If we're not caching, or if we're caching but we don't have any free objects, we need to make a new one. And so the way that works is, first thing I do is, if for some reason, I always do this in my own code, particle style is an option. But let's just say for some reason somebody just said particle get and they didn't pass anything. Well, I want it to default to the first choice so that it doesn't crash. So particle style is equal to whatever they passed in. Let me make that a little bigger. Or if they didn't pass anything in, I will set it to 1, which means it'll create a circle. So this is just a safety code. Let's see, if caching is nil, again here, I'll assume that if they pass in no arguments when they call this, that it's going to create a circle, and caching will be turned on. Again, this is purely safety code. In fact, if you wanted to make this even more accurate as a test, you could just remove this code and be sure that you pass in values, because that little tiny bit of code there maybe it'll affect your test. It runs 30 times a second. I don't know. I don't think so. Or 30,000 times a second, so that could be a little bit more hefty. You got to remember that every piece of code in here is running one time for every object we create in every other frame during the test. So this function, this method, is getting called 30,000 times a second. Ideally, it's if you're creating 1,000 objects at a frame rate of 60 frames per second. Of course, it won't keep up with that, but that's what we're hoping for. Next, I create a local variable that I'm going to store my particle in, and this is the part that does all the magic. Are we caching? No. Then we fall into this. Okay, yes, we are caching. Do we have any free particles? In other words, are the number of free particles, or our table of free particles, is the number of particles in that list greater than 0? Yes. Then we can reuse it. So we're caching and we have something available, reuse it. In all other cases, we need to create a new object. So before we go there, to reuse our particle or an object, I keep saying particle, all we have to do is get the last object out of the table and then remove that entry from the table. And then I put a little marker on the object, and I say in use. And I use that for my own code so that I know later that I need to recycle this object. And I'll show you that in a moment. So again, get the object from the last entry in the table, remove that entry from the table, and then mark it as in use. And there's one more step, but it comes below. Assuming, however, that we're creating a new object, then we're going to create one of these 4 object types. and we have a little if statement here. If particle style 1, we create a new circle. We recreate it and put it way off screen at 10,000, 10,000, or 100,000, 100,000. And I just chose a random size for this test, so I made it with a radius of 10, which is the equivalent of a size 20. So this is going to be 20 pixels wide and tall, just like the rectangle and just like the image. The sprites are whatever the size of the sprite sheet that they come out to be, so that part is not exactly the same in terms of width and height. If it is a rectangle, again, I put it at 100,000, 100,000, so I initially created off-screen. Same thing for the image rect, and same thing for the sprites.
I'm sure you're going to get to this in just a second, but why do you create it off-screen?
The reason I created off-screen is to avoid artifacts. And the artifact is, I got to create it somewhere. So let's say that I chose instead the center of the screen. Now let's pretend that I'm creating it at the center of the screen. This should never happen, but I like to avoid it. What I'm trying to avoid is a situation where I create it someplace, but it's really supposed to be at another position. And in the time after I create it, the frame elapses, the frame time elapses, and it renders, but it's in the wrong position. So it's not only in the wrong position, but it's somewhere where I can see it. So I don't want that. What I want is I want it to be initially created somewhere where I cannot see it, and then I'll move it to where I want it. But if for some reason it renders in the time between creation and placement, then it's still not going to look bad. It's not going to be like zip, pop, 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 pop. You know, like old school games back in the days where they did bit blitting. You'd kind of see this in like performance issues where objects would get created in the wrong place and suddenly pop to the right location. So it is my preference that objects be created off screen to start, or I could have explicitly passed in an x and a y value on the get, and that would have solved this. Then I would have simply created it at that x and y. But for the purpose of this test, I wanted to create a consistent initial placement and then later movement, so that I would get a better how do you say it? I would get a better, more consistent result. Again, these are all things that people can change when they want to experiment with this, and if they find a more convenient way of doing it or a different way of doing it that more accurately resembles their code, by all means do it. Okay, so at this point in the code, we have popped into this if statement if we're caching and we have free particles, or we've come into this else statement and we've created a new object. Now, at this point in the creation of new objects, we have to decide, are we caching or not caching? Because this is a new object. So if we are caching, we're going to create this method called release that's going to do some work. But if we are not caching, what I really want release to do is simply remove the object. And so the cheapest way to do that is to assign display remove, the function, to the release function, our release function. And so later when somebody says particle release, what will really happen is it will be as if I said display. So if they type this, it will be as if they type this. Those two lines right here are equivalent because of what I've done here. And in fact, this is safer than if I did could have done this. But I don't like the remove self function because I find it extremely unsafe, which is another topic. But if you call it twice, the second time it will crash, whereas display remove never crashes because it has a safety check. So if I'm going to use display remove, or if I'm going to do removal, the simplest way again is simply to assign this function to this variable, and then later when I call whatever I call it, particle, circle, whatever I call it externally to this function, and then I call release, it will be as if I called display remove on this particle. So that's very, very simple. So in the non-caching case, all it does is remove the object. In the caching case, it does a lot more work. So we call release, and the first thing it does is say, if this is not in use, you called it twice, don't do this again. So this, if the object's not in use, it's already been put in the cache. For some reason, you called release twice, and that's wrong.
And
But,
the in-use flag is something you said earlier. You showed us that.
right.
So
The in-use
that's something
flag
you said.
is here when I pulled it out of the cache, or below here after creating the object. So you'll have to read through this code to see it, but there's two places where I set it. But basically, when I pull an object or create an object, I set it to be in use, but only if I'm using the caching functionality. Because what's the purpose if I'm not doing caching? So if it is not in use, what do? I move it off screen again. I guess I could make that 100,000 to be consistent with the creation. I move it way off screen. It's no longer visible. It's not likely to be rendered. Now, maybe your game has 100,000 by 100,000. Just make the number bigger. You could just do this. Math huge. Math huge is the biggest integer number you can get. It can't be any further off screen than that. Mark it as in use is false. It's no longer in use because we're about to put it in the cache. Remove that. Here's a very expensive operation, but remove that particle from the list of used particles and put it on the list of free particles. And then finally, this is very important, you may have inserted this object into a display group. You want to remove it from that display group, because if you destroy that display group, and even though you've set it aside, if it's still in the display group and you remove it, the group, that will automatically remove the object too, and then your code will eventually crash. So what we do is we insert it into the current stage. Current stage is the top level parent group that contains and owns everything. And that group is around from the very moment the game starts until the game exits. So there's no chance that anybody will destroy the stage if they mean to continue playing. Once you destroy the stage, the game is over anyways. So again, what we're avoiding here is that the object should have been inserted, may have been inserted into a group. We don't want this object to be automatically destroyed if the group is destroyed, so we extract it from whatever group it's currently in, and we put it into the current stage, and that way it's safe. It can be safely kept aside. It's not going to get destroyed. Then after we have attached this function here, we mark it in use, as I said, and we put the particle in our used particles list. And then finally, we fall out of this if-then-else set of statements, and we return the particle. And that is it. So in a nutshell, it comes in. We decide, are we caching, not caching? If we are caching, we try to find a free object. Failing that, we then create an object. But if we were not caching, we would also create an object. So either we're caching and we have no free objects, or we are not caching. In either of those cases, we then create the correct object. We attach the correct release function for either caching or not caching, and then we return the object. So this little piece of code, it's fairly simple. It could be a little bit more optimized depending on your usage. What I wanted to do was basically leave it simple so that people could modify it and get results that are as accurate as possible based on their usage.
Okay. You can't ask for better than that.
Well, I don't think that was a 25-minute segment, which is what I said this was going to be.
Well, there's lots of questions there. I think that's a good conversation to have. Everybody had good points, and it's always good when we have a discussion about these things rather than just sort of muscle through them and just get it done. All right. Well, that's so that's object caching, and you said at the top of the hour that you felt like it was worth doing all the time if you have the inclination to.
Okay, it's worth doing in any scenario where you're going to be creating the same kind of object over and over in a tight loop.
Yeah. Well, there you go. All right. Well, Ed, I want to say thanks for putting all this together. This is certainly an eye-opening exercise, and I think that people should download the code and go through it and put it in their tool chest.
Another thing they should do is download the game that this came out of, and you'll see the same code in there but slightly modified for the usage in that game. And that game is now fully documented and released on the Git. So when people watch this show and download it, they'll be able to, it'll fully functional, fully documented, ready to go.
Okay.
A much better example of caching than this.
All right. Well, we'll put a link to that in the show notes. And I also want to thank Mike and all the other forum stars who participated in getting you data, because it's one thing to create this and have a question, but you need lots of data points in order to make it usable and beneficial to everybody.
And thanks to Mike too for pointing out a particular testing variation that I didn't even think to do, which is the variation on number of objects created.
Yeah, that's definitely interesting to see that there may potentially be a point of diminishing returns. So interesting. All right. Well, we'll be back here next Monday at 12 p.m. Pacific to talk all about cross-platform app development using Corona SDK. Until then, have a great week. Happy coding.
Auf Wiedersehen.